Good day and welcome to EDMS. If you want to succeed in engineering, graphic and design, it all starts with using the correct drawing instruments. Now in today's video, I'll be showing you the essential tools every EGD learner needs to improve accuracy, boost your marks and draw with confidence. This video is proudly brought to you in partnership with HSE Technical Education Solutions, specialist in quality technical education resources and equipment. I will link their details in the description below so that you can go and check them out. First up is your drawing board with a T-square. This is the foundation of every EGD drawing. The drawing board provides a stable flat surface while the T-square is used to draw accurate horizontal or vertical lines, borders or title blocks. If your T-square is not straight or not used correctly, your entire drawing will be inaccurate, and that means lost marks. So, if you have a look at the drawing board, you will see that the T-square has a locking mechanism on this side and on this side. The locking mechanism is there to lock the T-square in place. Now, not all T-squares have a locking mechanism on both sides. If you can get a drawing board with a T-square with two locking mechanisms, this will allow you to have a more accurate horizontal line when you draw it. If this side is unlocked, you can see that the T-square still has the potential to move a bit. Looking at the drawing board, you will see that there is a space for you to press to open the flap here on the side. This is the part where you will be inserting your page to ensure that it is fixed onto your drawing board. Some of your drawing boards will also have a flap that you can open down here. So if I move my drawing down a bit, I can then open the flap down here to put the page into the drawing board. It is crucial to make sure when adding the page that one of the border lines lines up with your T-square. If the border line is not in line with the T-square, like you can see here, it's a bit off there, you need to adjust your page so that the border line lines up with the T-square. You will be sliding your T-square in this groove, either on the left or the right, or at the top or bottom. You will be sliding in these two grooves on the sides to draw horizontal lines, and you'll be sliding at the bottom and at the top to draw vertical lines on your page. You can see that the border lines up with my T-square, so this means that the page is inserted correctly. It is good practice to always clean your equipment with either a dust cloth or you can just rub it against your pants before you start with a drawing, because if you are going to slide this, you will put some lead onto your new paper. Then you need to get yourself a nice drawing board bag, especially a padded bag which protects your drawing board and your equipment. So you'll put it in here, you are going to unzip it like this, and then you will put all your instruments in the bag to protect them. Next are your set squares. They are used for vertical lines, angles, and inclined surfaces. The 30-60 degree set square is essential for asymmetrical drawings, while the 45 degree set square is often used for diagonal and construction lines as well as hatching. In EGD, precision matters and set squares ensure your angles are exact. Now let me show you how to use them. Now it's important to ensure that your triangles are always flat against your T-square. When we slide the triangle to the left or to the right, we must ensure that the bottom of the triangle is flat against your T-square. This will ensure that you will get an accurate angle. Now, looking at this triangle, we know that this is a 30-60 degree triangle. If I rotate the triangle like this, we will get a 60-degree line over there, or angle, and we will get a 30-degree angle line over there. If we rotate the triangle like this, we will get a vertical 90-degree line on that side, and on this side we will get a 60-degree. If we rotate the triangle like this, you will see that this stays 60, but this is just in the opposite direction. So this is your 60-degree triangle. Always make sure that you put it flat against the T-square. This will ensure that you will get accurate drawing angles. When we look at the 45 degrees, you can put the triangle on this side. Make sure that it is flat against the T-square. You will get a 45-degree line and a 90-degree line. If we put it like this, flat against the T-square, you will get a 90-degree line and a 45-degree line. If you put it like this, flat against the longest base of the triangle, you will get a 45 on this side, and you will get a 45 on this side. What is nice about these two triangles is that you will get additional functions. So you will see that you have a protractor here, which we'll deal with a bit later, and you get some hatching lines over here. On this triangle, you get a circle stencil, so you can draw circles without using a compass. If you want to use the triangles on a vertical plane, all that you do is you need to ensure that you put them flush against your T-square, and then you slide against the T-square up or down. The same with the 45, you just slide, you make sure that it is flush against your T-square to draw the specific angles. And that concludes our triangles. Next up is a compass with a clutch attachment. A compass with a clutch attachment is essential for drawing accurate circles and arcs. The clutch allows you to use a mechanical pencil lead, which improves line quality and consistency. Now, whether you're drawing mechanical components or layouts, freehand circles are not acceptable in EGD, except when it's specified in a question. Now, if you look here, you can see that there's lead in this mechanical clutch pencil here, and if you press this upwards, the lead will come out. Now, I'll show you quickly how to use your compass. Looking at the compass, you will see that you have this big wheel here in the middle. This wheel is used to adjust the width of the legs of the compass. You will adjust the legs of the compass according to the given question. Now, for an example, let's say you need to draw a circle with a diameter of 40. We will need to adjust this compass according to the question. When setting up your compass, we are setting up the radius. Why? Because we have the middle point, which is the sharp point here, and then the lead. If I put the sharp point on the page and draw the arc or the circle, we are basically drawing the radius from the middle point to the lead. So if I want to get the radius, I know it's going to be half of 40, which is 20. So you are going to use either your drawing board or a ruler to set your compass to a radius of 20. I will be using the dimensions here on the side of my drawing board to get it to 20. So I'll adjust the legs of the compass to 20, like that. It's on 20 there. And then, depending on wherever you need to draw it, let's say you have a middle point over here, I will put the sharp point on the middle point to draw the circle. Now, it is important not to hold the compass at the two legs down here. You get a lot of students who tend to do this. This is not the correct way to construct or draw a circle. You should only use one hand with your fingers here at the top point, there at the head, and applying enough pressure downwards onto the page into your drawing board, you will be able to draw a circle. Now, it's important not to stop applying pressure while drawing the circle. When you do not apply enough pressure downwards into the paper and drawing board, your compass will usually slip out of your hand and make a mark. So, always apply pressure downwards with one hand, press into your drawing board and draw your circle. This will need some practice, but you will get used to how to use your compass. The protractor. The protractor is used to measure and draw exact angles. Guessing angles will cost you marks. Any angle that is not standard set square angles must be measured accurately using a protractor. Let me show you how. Like our set squares, we need to make sure that our protractor is flush against our t-square. This will allow you to get an accurate angle. So let's say I wanted you to draw a line of 35 degrees. So let's say our starting point is over here. I'm going to make a starting point there. We need to make sure that the middle point of the protractor is on that middle point there, or the dot that I made. So I can move the protractor by using the t-square as well. I'm going to slide this up and down to get to that specific point, and then I can slide to the right, so you can see it's in the middle over there now. And now I can go measure off 35 degrees. Reading from the right side upwards, 0, 10, 20, 30, 35 is over there. I make myself a little mark, and then I can just connect the two dots. And that line will be then an accurate 35 degree line. And that is basically how you use a protractor. Next, you will need to invest in good clutch pencils. You will need two, a 0.3 and a 0.5 millimeter clutch pencil. The 0.3 is used for light construction lines, while the 0.5 is used for your final visible outlines. Now, using the correct line thickness shows good drawing practice and earns method marks. Now, to be honest with you, in my 15 years of drawing, I have only used a 0.5. You will be able to do everything with only one clutch pencil, which is a 0.5. When buying a clutch pencil, look for a clutch pencil that has this metal long point. This point here supports the lead, and it makes your lines much neater. Now let me show you how to use this so that you can do construction and final lines with only a 0.5. Now when we do construction lines, you should never press hard down into the page. It is a soft light line. That is a construction line, and they usually use a 0.3 for that. But you can also do it with a 0.5, and I'll show you. All that you do is you don't apply pressure with the pencil on the page. You just rest the pencil in your hand and you just guide it along the T-square here. So I'll draw a light construction line here for you. There is a light construction line. When you do a final line that you usually do with a 0.5, you just apply a bit of pressure onto the page in the clutch pencil and you draw a dark line. You can see that there's a clear difference between the two in darkness. A construction line is usually lighter and thinner, and a final visible line is dark and a bit thicker. But you will be able to do both with a 0.5. Next is your eraser shield or a eraser plate. An eraser shield allows you to erase small areas without damaging surrounding lines. This is especially important when correcting construction lines or intersections. Then you also need to invest in a good quality eraser. A good quality eraser keeps your drawings clean, and when you have a dirty eraser like this, it is going to make smudges and dirty patches onto your page, and that you do not want, because you get marks for presentation when it comes to course drawings. So you want a clean quality eraser, and you need to use your eraser shield if you want to correct some lines. And I'm going to show you how to use this now. So let's say you made an error. You've extended that line too far and that little line over there too far. You will be using your eraser shield to erase that lines that is extended beyond that corner point. Now I'll zoom in a bit here to show you what I'll do. I will use the eraser shield, move it so that the bottom line here, you can do it with any line here, you can play around, but I will move it to that point over there, and I will then just erase that extension line over there. You can clearly see that I've removed that line over there. I'll move it to this side, set it up to that line, and just erase the extended part. And there you can see the lines are corrected. Another nice feature that most don't know are these little circles here, which can make a line a dotted line. So let me show you. Let's say this line you've constructed, and afterwards you've realized that that line should actually be a hidden detail line, meaning a dotted line. You can take your eraser shield, you can put it on that line, and you can use a good quality eraser, and you can erase all the lines in the circle, and it will form a uniform, equal length dotted line. Next are French curves or a flexi ruler. They are used to draw smooth, irregular curves that cannot be drawn with a compass. These are essential for CAM profiles, design curves, and technical shapes where accuracy and smoothness are required. You will typically use them in grade 11 and 12 and not in grade 10. So you could put them on the side for grade 10. You can acquire them, but you will not use them. You will play around with the different French curves to get the acquired arc, or you can use a flexi ruler, which you can bend and set to a arc that you need. Then a circle stencil. A circle stencil is used for drawing small, accurate circles, such as holes and symbols, and it saves time and ensures consistency, especially when multiple circles of the same size are required. So with these small circles, it is very difficult to draw them with a compass. So you will use a circle stencil to draw these circles. It's very important to line up the circle stencil with the center points of the circle. Now, if you have a close look here, you can see on the circle stencil, there are little dots which indicate the middle points or the axis, the vertical and the horizontal axis of the circle, which indicates the middle point. Now, you get circle stencils with a little dot, or there will be a little line. So to ensure that this circle is drawn correctly at the given center point, I'm going to line up the dots on the center lines. The numbers that you see here at the circles, that indicates the diameter. So if I want to draw a circle with a diameter of 20, I need to go find the diameter of 20. So there's 23, 22, 21, so 20. So it's this circle. I need to line up the dots with the center points. And this ensures the circle is drawn at the correct place and it is placed accurately in the middle. Then a calculator. A calculator is often overlooked, but it is extremely important in EGD. It is used for scale calculations, conversions, and measurements. When you have an incorrect calculation, that leads to an incorrect drawing and you're going to lose marks there. So make sure that you have a calculator which you keep in your EGD bag. Then some masking tape. You will use some masking tape to tape the edges of your page onto your drawing board to ensure that the page don't flip. I'll show you how to do that quickly. So some drawing boards don't come with this flap to ensure your page onto the drawing board. So you can use some masking tape. Just take a little bit, tear it off, and then like this corner over here, you can see is still loose. When you use your set squares, sometimes it can get under that corner and it will pull up that corner and cause it to bend or tear. So what you can do is you can take a bit of masking tape and you can put it on that corner to secure that corner down to the drawing board. Luckily for you, you don't need to go source everything separately. HSE got you covered. Let me show you what's inside. So if you open it up, you get everything in here. Your compass with a 0.5 mechanical clutch pencil added on there. You get a nice quality clutch pencil over here, a pilot. You get some pencil lead, 0.5, a good quality eraser, some spare parts for your compass. If you're still old school and you want to use the lead for your compass, you can use this attachment. You can just remove that mechanical clutch pencil and you can use this. We have a 45-degree triangle over here, some masking tape, a 30-60-degree triangle, a ruler, and a eraser shield. All this compacted in one package with a nice foam board added inside to protect your instruments. You can zip this up and put this in your drawing board to keep it all nice and tidy and together. I will put their details down below so that you can go and check it out.